Hey everybody, this is Larry. This is me going Q4 of the weekly contest 438. Maximize the distance between points on a square. Hit the like button, the subscribe button, join me on Discord. Let me know what you think about this one. So this one I thought was very tricky, but also doable, unlike Q3, frankly, unless you knew something. But yeah, I think the first thing that there are a couple of visualizations that I would like. Actually, let me bring up the drawing board real quick. Right. Okay. The first idea is that everything is going to be, I mean, it's a square, but honestly, I thought of it more of a circle, right? Because they're just points on a line. And the thing is that from a points on a line thing, pretend that's a square. You have these points, right? And because it's a square, one thing about these squares is that a cross doesn't matter, right? Because let's say you have these 2 points, right? Even though technically the Manhattan distance is side, you're not going, and because you're choosing at least 4 points, the constraints make it so that going across doesn't matter. What do I mean by that? What I mean by that is that, for example, if you have a square, well, there's only really, like, if you have to choose 4 points, even if they're all spaced out in the corner, that they're side apart, and if they're right, so that means that the answer is going to be at most side, which is the length of the one side of the square, right? Because given 4 things, that's it, right? Like, this is the best case, and as a result, you don't have to think about things across from you, because at most, or at least, it's going to be the length of the side plus a little more, right? Okay, so that means that for this problem, let's say we choose this one, right? That means that the shortest, so everything across from you, it is going to be at least L, right, for one length of the side, so we don't have to care about them, because, well, if you have, because the answer can at most be sides, right, so you don't have to worry about that. And why do I say it that way is because then now we just try to figure out what the length of the adjacent ones are, right? So that means that, yeah, and this one goes kind of loop around a little bit because it's Manhattan distance. You can kind of, because of Manhattan distance, and we don't care about the acrossness, you can kind of unroll this square, right? And what I mean by unrolling the square is that you just kind of, it goes here, it goes here, it goes here, and then maybe it goes here, but then now you can think about it as unrolling as this is one side, this is 2 sides, this is not me. This is me in the process of unrolling one. Like, if you want to draw the corners, this is the corner, this is the corner, this is the corner, this is the corner, right? And we just kind of unroll one of them. And if you unroll it 3 times or whatever, then now you have if you unroll it 4 times, then now you just have a side, right? A line that is side times 4, right? And you can kind of think of it as, maybe I will redraw this a little bit, right? Also pretend this is a square, and let's say you have these points, you can kind of just map them to those points, right? For example, maybe you can say, let's just say we start, this is the origin, and then here, this length, then we can put the first red here, this length, we put the second green here, this length we unrolled, so maybe this is here, and so forth, right? So you kind of map it this way. Maybe that's too close, but you get the idea, right? On the 1D plane. And then frankly, so this is the way that I did it during the contest, and I was trying to be like, okay, that makes sense, because, well, now that we have this line, we can just binary search the target, which is the minimized thing, right? So that's going to be log the length of a side, which given 10 to the 9 is going to be at most 30 loops, right? So not a big deal. So that's 30 iterations, binary search, we're fine, right? So then in one iteration, my idea was that, okay, we can do greedy, right? So we have k is equal to up to 25. I thought during the contest incorrectly actually, but I thought during the contest that maybe there's some pigeonhole thing where, for example, if we have this line, if we have this line and k is equal to 2, that means that maybe we can skip the first one and then maybe skip the, like we can test the first two or the first three things, right? Maybe that's what I thought. This is wrong, by the way. I thought that maybe I could do the first three things and then I could brute force the rest. What I mean by brute force, or sorry, not brute force, greedy the rest, right? And what I mean by greedy the rest is that, well, you know what the target is for our binary search. So if the target is equal to 5 and we start here, well, the next number there's a greedy way, which is the next number that is 5 or less, right? That means that this goes to here, maybe, if this is too big. Maybe this goes to here, this goes to here. And then you just count, if you count that if you count that you could get 25 numbers, then k numbers, which can be at most 25, k numbers, we are good, right? I don't know why I wrote it so, this is why I don't like to use the pen. But yeah, so we have k numbers, right? And then I thought incorrectly that I could pigeonhole this. So, okay, so I was very wrong. That was one of my wrong answers. Actually, like 2 or 3 of my wrong answers because I thought maybe I was just wrong on the pigeonhole. Maybe I could choose a bigger, I chose search skipping k plus 1. That wasn't good enough. I wrote k, I don't forget what I wrote. Or the variations. I think maybe k plus 100, it was still not good enough. K plus target should be good enough as a result, but that times out because target could be n, and then it just ended up being n squared. N squared is too slow, right? So those are the things that I did, and then and then it turns out that the way to resolve this is let me actually, before I talk about that, is that because you know which one you started at. Let me draw another way. Because you know which one you started at, like say here, here, or here. We can look at the last number. Well, if k is, if the number of things that we added is already greater than k, we can return. But if the last number that we added is too close to the first number, and by too close I mean by wrapping around, meaning if this plus this area is less than the target, then that means that they're too close in a wraparound kind of way, right? Visually, you can look at this square again. It just means that this area is too close. You can do some math to make sure that's the case. But yeah, so there's an easy way to check that. So then now, and the way that I did it again is that I just go for every cell, but only starting at the first k or whatever element, which is wrong. But I go, okay, well, we start at this one, we look at this one, is it enough space? No. We go here, is that enough space? It is. Then okay, then we move the point. Let me use another color. Chaos. Okay, so yeah, so for example, you start here, and then you go here, and then you just mark this one. Then now you check this one, and so forth. And as a result, because I was trying this because I thought that k times n is going to be 25 times n, which is fast enough, right? But it turns out that, again, that is just incorrect. Like I used 2 or 3, maybe even 4 wrong answers trying different things, and it's just wrong. So then I kind of had to step back a second and just thought, okay, I thought that this idea was right and agree. So I knew that my solution was right? Except for the k part, except for the starting part. So it becomes clear to me that my answer is wrong because of how I choose to start, right? And I was choosing to start from the first k. I thought maybe there's some pigeonhole thing that I can use, but it turns out that you have to start from something in the back to get the answer. It turns out I don't actually know why that. Well, maybe I wasn't tight about this, but it's just for a certain distance. It just may be that, like for example, if the first k elements are really close together, and then you have a lot of them, and then at the end, let's say all the spaces are 1, right? And then here, all you need is just like all the spaces are 2 to get the answer to be 2, right? For any k, right? Like if k is equal to 10, you could just have like, I don't know, 1,001 spaced things, and then start with the 2 spaced things, and then the answer would be 2. But if you only look at the first K, it was just that way, right? So okay, so I kind of had to verify that you have to start from every cell or every point as a starting point, right? This is a very good example. You can kind of arbitrarily do it. I mean, yeah, at least without doing n squared, that's gonna be too slow. So then the next thing that I did with the optimization is that I thought, okay, well, these are gonna be too slow, so I have to start at every point. How do I solve it from every point? Well, it turns out that I only need k is equal to 25, and that's where it comes in again, where I could take advantage of it. It's because then now, if I'm able to adjust all these points in a way such that I can binary search again, the second binary search, because then now, let's say this point is at, and I'm using 1D numbers, let's say this point's at 10. If your target distance is I don't know, 20, and you have just points at like 12, 15, 25, right? 35, then now you just do a binary search to see that the next number is going to be 35, right? Then now you jump over all this for log n time instead of whatever, right? And as a result, because we only have k of these or 25 of these at most, that means that you're going to do at most k log n operation per start, right? So per start, so we have n starting points for each one. We have k log n, and apparently that's fast enough. N is 10 to the 5th. Let me actually write on n is equal to 10 to the 5th. K is equal to 25. Log n is going to be, say, 20. I don't know, right? And yeah, and you could do the math, and it's going to be fast enough. And yeah. Yeah, and that's basically the idea that I have for this one. Some of the maths is a little bit wonky, a little bit more detailed, but we'll go over it, together. But yeah, but overall, there are 2 binary search in this problem. I also things that I explored a little bit. I just want to give you an idea before I go on of like all these things that I'm trying. Right? I actually don't know how long I took on this one because I end up skipping Q3. I don't remember when I skipped Q3. Actually, let me take a look real quick. What is this? 4:38. So I end up spending 40 minutes on this one as a result. So it's still a very hard problem, frankly, for me anyway. And I did try. I thought maybe greedy doesn't work. I thought maybe there's some k times n dynamic programming that I had to explore, but I couldn't make that work either because it ends up being k times n squared or something like that. But yeah, but those are the things that I played around. So those are the time that I spent 40 minutes on. So you can watch that part live as well. But yeah, so there's a lot of ugly code, but the way that I unwrapped it, I tried different ways of unwrapping it, but I couldn't figure out like a clean way to do it. Maybe there, not to say there isn't, just that I didn't figure it out during the contest. So the way that I did it with the top is to split up the square into 4 sides. We have the bottom, right, top, left going in one direction. I think without loss of generality you can do either, but I don't know, that's the way that I did it anyway. So then now, if y is on a 0, we have the bottom side. If y is on the top side, this is the top side. And the reason why I wrote it like this is because that I want the bottoms and the top to have the priority. And for the reason of double counting, so I guess you could have added a set and maybe made it a little bit less wonky. But it's so that if you have a point at the corner, I want it to be either on the top or the bottom. So that's why I kind of wrote it this way, right? You have the bottom and the top just take up all the sides. Otherwise, if it's on the left or the right, we want to make sure that this is not on the top or the bottom. And the same thing here, right? And then now I just go around. I sort them going around. So then now we have the bottom, we have the right, we have the top. Actually, I don't need this anymore because I was using it in another way, on the time limited exceeded way. But yeah, but basically you just go from bottom, and the natural sorting is good. Going from the right side, from bottom and up, so the natural sorting is good. But the top side, you're going from right to left, so you have to reverse it. And then on the left side, you go from top to bottom, so you also have to reverse it. You just have to work it out. I worked it out live, so it's not something like that you have to remember or anything. And then here, Yeah, actually, I don't need this anymore either. I wrote this because if you watch the live version, you may see why I wrote it those way. But yeah, but here, there probably is a cleaner way to write this. But also this is wrong. Oh no, I think my okay, well, is this right? Oh, whoops. Oh, I see, I see. All right, sorry, friends. I actually did remember working this out, but I got me scared for a little bit, honestly. And the reason, okay, this is actually kind of ugly to look at, and the reason why I had to kind of work this way is because I couldn't figure out the symmetry between this. Like I was like x plus y, x plus y. So this does look very weird, right? And honestly, I kind of wrote this in a really weird way because I was pressed for time at the end. But yeah, but this is just the distance from the origin, right? Ooh, man. I scared myself for a second because I was like, this looks really wonky and it's a smell test. And it is because I wrote it in a weird way. But yeah, so distance from the origin after unwrapping as we call it. So yeah, so the reason why this looks awkward is because here I wrote x plus y, but here y is always 0. That is why it looks awkward, is because y is always 0, because on the bottom, y is always going to be 0. So then now the distance is just going to be the x component, right? And then now, here, yeah, and then now you go up to the right side. So then here, you already traverse one side. So then now you go up, right? So then as a result, this is side plus y, right? So you have what? I mean, I had x plus y, but because x is equal to side, so that's why it looks that way, is that, even though it's very confusing, and it's yeah, it's very confusing, and this is one of those things where if you wrote code in that way, it makes it unreadable. Not that it's unreadable, you could reason it out, but it's more unreadable, right? Even though they mean exactly the same thing, this is an example of something that is more difficult to read. And I wrote this code only I don't know, an hour ago, not that long ago, right? So it's not like I have to go back. So when people talk about, clean code and stuff like this is kind of an example because I scared myself. I was like, did I mess this up? Did I, am I going to fail system testing again? I mean, I might for another reason, but at least not this one. But yeah, so okay, so now it looks kind of more like it looks cleaner in the way of the progression, right? Anyway, from the right side, x is equal to side, which is why the other formula worked. But and so you unwrap that x side, and then you kind of go, well, now the height is going to be the delta. So that's basically how I did it. And then now you do the top. Well, the top, you already did 2 sides, and then you want to count from the right corner, which is why I did it this way, right? And then the last one is, you unwrap 3 sides, and then this is the distance from the top, which allows you to do this. And the reason why also the variable names and stuff is a little bit funky is because I was a little bit lazy and I was trying to compare 2 adjacent points instead. You could see this wrong answer, by the way, on the live portion. I was looking at adjacent elements, but as a result, I did the math wrong because if you don't have a point in P sub right, then on the right side, then now your Manhattan distance is wrong, because you don't count the wrapping around. So I did it wrong that way, that for one wrong answer. But thankfully it was easy to resolve. But yeah, but writing it out like this, now you kind of map each point from a square to the thing, right? And then that's it. I know that I don't really focus on the binary search for this video. I mean, after all, it is a Q4, and it is an 8-pointer, so you have to really know your binary search. You just have to know it really well, because if you spend 10 minutes on binary search, you know, if I spent 10 minutes on binary search, I wasn't going to get this one, right? Like I was way close to the end. So yeah, so that's just my perspective. So I'm not going to go over that very deeply. There are a lot of binary search videos, right? But yeah, I just go, okay, so just to be clear, I know that the smallest has to be 1, and then the max size has to be a side at the 4 corners. But even if you kind of rotate the 4 corners thing, it'll be the most will be side because you have at least 4 numbers. Anyway, so then yeah, this is for a given target. Can we space it out with target as the answer, right? That's a very awkward way, but yeah. And then the target, this part is just very yeah, it's just greedy. So then now we greedy start at every point, and keep in mind that we don't have to wrap around because yeah, I mean, you can if you really wanted to write it that way, but you don't need to, because the reason why you don't have to is because if you wrap around, it is equivalent as starting as the other point that you wrapped around to, right? Meaning if you wrapped around and it goes around to like index 2, well, you could have just started at index 2. So that's why wrapping around is not necessary. Also makes the math a bit easier with the binary search. But yeah, but that's basically the idea. So then now we just count, because now we have one point chosen, and while it counts less than k, this makes it O of k, right? Then now we do a binary search. Again, this binary search is going to be log n, and then to get the next index in which you have the current point plus target. We do 2 checks. If this goes off the boundary, then of course we just ran out of points. We want to break. Otherwise, if if we wrap around, if the point we just added is too close to the point that we started at, we also break, right? Because that means that it's too close. You can't add any point, and you can't even add this point. And every point that you're going to go in the further is going to be too short anyway. So we break. Otherwise, we update this as the current index. We increment the number of points we added, and that's it. And keep in mind that this ends at count is 0 to k. So if count is 0 to k, we return true. So we don't even have to we don't have to deal with the rest of the number. Otherwise, we choose all the numbers and it's false. As we said, this is going to be O of n times k times log n, right? And yeah, and that's all I have for this one. Let me know what you think. Let's go over. Let's just do a quick scan it once more time. We just kind of sort them out by the 4 sides, sort them in order, and then calculate it from the distance from unwrapping. I guess I should. The reason why yeah, I mean, I guess looking at it this way, you could have also, you don't need these sort. But the reason why I had it was because I was going to do it, I was going to walk it one at a time. So I didn't want to change this code because I was walking it. It didn't matter. I had to do it in order. And I didn't do this 1D conversion until later on when I wanted to do the binary search. Because when I didn't need to do the binary search and I was on the wrong pigeonhole thing, I thought I could just look at 2 adjacent things, right? So actually here this doesn't matter, and then now you can just do points to that sort. So that'll be slightly faster, maybe. I don't even think this is faster, but it is cleaner to write, because the reason is because now you're sorting more elements, where before you sort 4 smaller elements and then combine them, right, in the order that you knew. So I don't think that I mean, it's gonna be right, but yeah. Anyway, so that is just calculating all the points. This is a very standard binary search, and this is a greedy binary search going for the thing. And that's it. That's all I have with this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live during the contest next. All right, Q4. Apparently I don't know how to do this, so let's just do a Q4. Apparently a lot of people know how to do it though. Am I being dumb? We did it in 8 minutes. Let me give it another dot real quick. Yeah, this is. Do we need to know that one? This one? Oh, this is a bad one. All the last digits, almost all, which is almost as bad. How do I feel? Okay. Is this fast Fourier transform? I don't know how it is. Alright, let's go cute way. I'm just gonna suck it up. Alright. You have a square. Choose k is equal to 4. What's k? Choose such that. Okay, so you just put on the 4 corners. This one you have. What? Oh, you have to choose k of those points. So you have all those points and you have to choose a subset of them. But they're all within they're all on a square. K could be at most 25. There could be a 1500. What's that? Oh, 1500? No. 15. No, yeah, 100. No, 15,000. Why do 15,000? 15,000 choose. Is it binary search? The circularness is kind of it's Manhattan distance, so you can think of it as a circle, really. Is it binary search? Why 25? 25 is so that you can do DP maybe on the binary search. If it's binary search, it would be greedy until the last number, right? I don't get to 25, honestly. Was is that the first point? I mean, I guess you could skip. Do you want to skip that many though? Are they all ints? They are ints. I don't get it. I don't get why this one is hard writer. It could be more than that actually. Well, no, it has to be at most side. So I guess that part is good. I got it wrong last time, but if this is good, then let's try something bigger. Otherwise, let's try something smaller. I don't get the constraints. I guess we have to sort this in a smart way. Distance from... we have to sort this... yeah, that's not that bad. Okay, so... was it? Is it y? Y is equal to 0. That's annoying. if x is equal to side, then it is on the right. But we don't want it to be if y is not equal to 0 and y is not equal to side, so just not top and bottom. Else if y is equal to side, top dot xy, else p left as long as y is not equal to 0. Right, okay, and then now we just have to sort. Top sorting is, well, bottom sorting is straightforward. The right, we want to sort by all the x's are the same, so we, okay, so sort is p top, we want to sort by reverse is true, and p left reverse is true, and then it is just points is equal to right. Okay, so then now we have a good function, we have a target. Is it that straightforward? I don't know. Do we always choose the first point? The answer is no, so that could be the point of contention, right? How do we choose the first point? Is there a pigeonhole thing? So target. So that means at most. I'm just doing calculator. 1500 times. Okay, so given a target, pigeonhole means the first target points, but you only do 25 points, so there is a smarter math here, because there are at most 25 points. That means that you should only cut off the start of the first 25. Okay, maybe. I don't know that that's quite what makes sense. I think that is reasonable, maybe. Okay, so then now for start in range of from, well, okay, that's fine, right? We want to say, okay, so current is equal to start, right? And then we want to go around, so for index in range from the start plus 1 to n, and no, I actually did define n. Then now we want to say if current, all right, so Manhattan distance, so yeah, okay, so if points of index of 0 minus points of current 0, so this plus this, if this is greater than or equal to target, then this is good. Then we have a count is equal to 0. Then now we have count is equal to 1. We have 1 point. Count increment, and current is equal to index. The only thing that we have to worry about is we have to check that this isn't too close to the start, right? Yeah, okay. So if this is true, then and if yeah, I'm worried about the calculations, but it's okay. If this is I guess this is just an AND statement, really. If count is greater than or equal to k, then we return true. So that's the early termination. Otherwise, we return false. And I think we may be okay. I don't know. How do I get index out of bounds here? Current is equal to start. Oh, so k has to. No, k has to be less than number of points, so that doesn't make sense necessarily. Why? Why is this out of bounds? Alright, well, is it the start? Nope. Oh, not just that anyway. Index, what am I doing wrong? What am I doing wrong? Did I mess something up? This is very weird actually, so that is wrong. That means that I didn't count one of these. Let me double check. Yeah, these should be the same. So okay, so that's an easy fix or easy to debug. If true, so bottom, top. Yep. Okay, let's just print them out. Print points and this thing. Okay. Why am I missing 2, 2? 2, 2. The side is 2. It should be top. So Y is side, right? So this is top. What is top again? Top is if Y is 2. Why is 2, 2 not in there? Sad. Oh, because this gets checked first. Okay. That is actually... I didn't think the order of operation would come out there, but okay, fine. Okay. 211, is that the actual answer? I don't know. But alright, we have 26 minutes. Is it worth taking a 5-minute penalty? I don't know. Yeah, okay, I'm a little bit lazy. That's just YOLO. It may time out. Okay, wrong answer is even worse. Expected 8, we get 1. That is interesting. So, okay. Yeah, I guess that's fine. I don't know that I would have gotten it, but okay, so these are the points. We want to pick 4, so it has to pick all 4. So why is it 1? Target. So we're just not finding anything here. Why? K is 4, so we start off at 0, right? I guess I have to put target. Okay, 22, so 0, we found 2. Well, 22 is probably too big, right? We want 8. So 6, for 0, we still found 2. Why? So here we go. So what is 41, 0? It's on the bottom, right? Yeah, 41, 0, 42, 7. Am I wrong with the Manhattan distance? I don't think so. Okay. Why? Oh, because wait, any 2 points, but no, I mean that doesn't make sense. You never, yeah, I don't think so. Okay, so why is 6 wrong? 6 is 2, why is it 2? Start count, index. Let's just figure it out. Okay. 6, 0, we find index 3. Why though? This is, I hope this is a silly mistake and not like something fatal, but I don't know honestly right now. Guys, and 602. Okay, so 25. See, oh, see, oh, wait, what? Oh, I'm just dumb. Okay, so that is actually really bad. This is no. Its index is current, right? So why would it be 0? This is a little bit awkward actually. That I kind of did. I mean, absolute value doesn't matter, but actually that's pretty bad still, for consistency's sake. I guess. Oh, that's because this is index and not. No. So something wrong is here. It is index minus start. That's why. Okay. Well, that's pretty bad on the. That's why you want symmetry. So that it spots you out, because something just weird on that one, right? 2118. Okay, so hopefully that's just a silly mistake. But I mean, it still may time out. I'm not sure on the timeout factor because I'm too lazy to do the math. But we'll see. Ooh, well, I'm not sure on the getting it right factor either. Huh. Okay. 46. So that means that we could be more aggressive and we're wrong. Maybe we had to choose more than the first 4. I thought we could skip by pigeonhole for 4, but maybe k plus 1? I don't know. Would that fix it? 53, yeah, maybe we have to skip the first 4 for pigeonhole reasons. I don't know that that's good enough though, honestly, but also k could be n, but this would never run. So okay, I mean, I'm willing to YOLO this just because I have no idea, right? Wouldn't be surprised if it's wrong, yeah. So then now, I wish that this came up a little bit earlier because I'm guessing that this k has to be like a little bit or a lot bigger, right? But I don't know what the number is. So yeah, so if we increase this, we get the right answer, but then, you know, then here you actually want n, but then you have n squared, which is also obviously not what you want. I thought it could be k by some pigeonhole, but yeah, I don't know. Maybe there's something about target, but that's still Yeah, I mean, binary search means that it's going to be just timeout, right? I mean, this is fine, but that's, yeah, I don't know. I mean, this is right, but that's because n is small. Maybe n is small enough. I don't know. All right, I think this is wrong, or I think this is too slow. But I'm going to YOLO because I don't really have it. I mean, I guess I have to figure out what the right number is really. We have to skip some numbers. It just means that we have to, yeah, I mean, I thought this would be n squared, but I was hoping that maybe n squared it will be fast enough, but clearly it's not. So how would I reduce this? Choosing the first point is critical. It's either that or we have to do some DP thing. It's not clear to me that DP is cleaner. Because you have to choose the start. The looping thing is the tricky thing here, right? So I don't know. And you could always choose, like, even if I choose 1,000, it's going to be a number that's bigger than, you know, it's still, well, 1,000 might still time out. I was hoping that there's some pigeonhole with K, but maybe I have to figure out a little bit better math with choosing the first point. I don't get it though. Why would it be better? Because you loop. Is there something with the loop? Is there like a sliding window thing with the loop? The thing is that this is greedy. But why doesn't greedy work? Because it's index K maybe? Can we do that? No, we have to figure out what the previous one is, and having the previous one is no Gucci. Well, you could do a binary search. For the next number. But yeah, now, yeah, you can. And because you only have to do binary search 25 times, then it's not O of n. Okay. Okay. Fine. Okay. Let's see. So then let's convert this. Okay. Yeah. Oh, okay, so let's just say the first point is, so then you have side, so then the side times 4. So okay, so we can just measure it from the distance from 0 on the thing, right? So then now, okay, so then, okay, for x, y in points, okay, you could get this, Larry. Focus, because then it's n times log n. Okay, maybe that's still too slow, but I think that makes sense. At least fast enough for me to go to Java if I have to. Okay, so here we want to convert it into the last point. Okay, last x, last y is equal to 0, 0, say. The distance, right? So absolute plus okay, right. Oh no, it's delta plus it's a prefix sum. So let's just start at 0. Okay, and then we just remove the first number, whatever. Okay, right? So then now, what would this look like? Let's reach for parity first. So, okay, so then now, also this is wrong. I don't know what happened here. Because I think there wasn't one of these like a 2 or something. That's pretty bad actually. I don't even know what the answer is, but wait, let's check, because I don't think okay, this is no, this is 53, and we have to choose k is like k 1000 or something just to kind of get the right answer. Let me screenshot this for okay. Okay, so then now that means that if points of index minus points 2 of index minus points 2 of current is greater than you go target, and points 2 of so you have to loop it around, which is index minus points 2 of start. It's something like this, but we have to wrap it around, right? And you wrap it around when start is plus side times 4, right? It's side or side. Yeah. Okay, that's not right. That's really sad actually. I was hoping this was right, but why? Okay, let's print. Zero, that's 2. This is not 2. Okay, fine. Oh, because I didn't do prefix sum. I said I would, but then I lied. Okay, hopefully this is fine. Okay, still not fine, but 6, 8, okay. 2, 3, 4, 5 is right. Why is it wrong? Okay, oops. Let's take away the beginning loop first. Okay, I mean this is wrong because we don't have to start. So start is wrong. So the start should be okay, so there's this. So each side is 2. So this is an 8, right? No, it's the okay. This is right. It's just that now you have to okay. Because that would never be true. Okay. Is this right-ish? No, it's still wrong, but what is this? The last 2. Why? 18 minutes. Should be able to get this. Oh well, maybe anyway. Why? The annoying thing is that the one I know the answer to, it doesn't, or like that I can work out easily, because there should be like 53 or something, but which one is this? Is this one? And it should be 53 or something, right? So y. So 8. Alright, let's see. Let's print. So this is wrong too optimistically. So we can do something like this maybe. 53 is good. 62 also thinks it's good. With the start of 0. Okay, so that's easy to look at anyway. So 1, 2, 3, 4. Side is maybe, but this thing is wrong maybe. Is it side times 4? Okay, so 13, which is not bigger than target. Oh, it's not current. It is index. Oh man, how did I make the same mistake twice on different things? Okay. Alright, so this is right, but this is still going to be too slow. So what do we want to do? What we want to do is now we want to binary search. So that means that, okay, for start in range of n, current is equal to start, count is equal to 1, and then we just binary search, right? So maybe k minus 1. Or maybe just while count is less than k, right? We go, okay, so then we want to binary search points to, oops, how did that get over bottom? Of the current plus target. So new index is equal to here, and then yeah, then current is just equal to index, count increment by 1. If index is greater than equal to length for points 2, then we break and no Gucci. So if count is equal to k, then oops, then we return true. Otherwise we just keep going and we return false eventually. Okay. Alright, so this last time, oh, the code was so fast last time. Code is also fast this time, but it's wrong, which is not as good, not as brand. Oh, we have to keep track of the last one, right? So okay, so okay, we have to write this part. Okay, so if then this is good. So that means that if this is less than target, then we also break and don't increment, right? Is that not it? Start right? Well, at least this is wrong for this one, so that's good. Index. It's not current. Current is wrong. It's points to of current. That's why it's so easy to find matches. Yeah, okay. Nice. I think this is right? Where's my screenshot? I'm not showing the last number anymore, but 23324. Okay, so let's go. Oof. I have 5, expected 3. We have 12 minutes. Hopefully I get to finish this. Okay, so I mean this is easy to debug. The key note is that we lost the number. So that no we didn't. Okay, so 2 8 you go 3 12, so 20 21 33. What is the side? 9 is 36, so it's 38, right? So okay, so it thinks the answer is 5. we want 4 sides, so 36, so 38. Is that not right? Am I misunderstood? Maybe I'm, well, that would be really bad if I misunderstood it the entire time. Then I'm just sad. But did I do the math wrong? Okay. Oh no, the points are here. So 2, 8, and so 2, 8, and then 5. 5, 4 is weird, right? Yeah, this is sorted incorrectly. On the right side, so that's not the right side, that's the left side. Did I do something wrong? Top left. Left is 0, 1, so this is the top. Okay, so top V1. No, that's the right side. Okay, which is actually, oh, because now we have to, okay, we have to connect it because we wrapped around, so the Manhattan distance is no longer true. Okay, so that is at most okay. What does that mean for me? Because each side is 9, so this should be at most 9. No, but you can't do it quite that way because then it wraps around a weird way. But the way that I calculate this math as well. Okay, that's fixable. Because this is maybe too close to something, I don't know. But something is off here. Also 0, 1 to 1, 0 is only 3 away, so yeah, the math is just wrong because everything is cascaded. Okay, so then here, okay. Okay. Let's just do it this way. P bottom, P right. No, let's, okay, so then let's just do it. Delta is equal to, from the bottom, it's going to be x plus y. Okay, that's fine. And that's not even the delta, let's just do it this way. Okay, we don't need this, we don't need this. We have 8 minutes, hopefully we're good. This is going to be a side plus plus the x element, so it's going to be x plus y anyway, right? Okay, and then now top, it is going to be side times 2 plus distance from the corner, so that's going to be n minus, or side minus x. And then left, it's going to be side, and then it is going to be side minus y. Okay. 3. Okay. I was just trying to be too clever, or just trying to be lazy on that one. I think, okay. Whew. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, these explanations. Yeah, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.